In France, studios of 13/14 years old are expected to pass a journey of a duration of 5 days in a working spot, uh, in which they would observe the other's work as well as participate. And I did that too a long time ago. I'm just going to present you just because I wanted to. So I did my stage in the IRCP, the Institute of Research of Chemistry in Paris, which is a research lab of the NCSR, National Center of Scientific Research, which is, well, in Paris, in the 5th arrondissement, so at 1 hour of train from home. So 3 hours of train today. The IRCP is composed of 10 thematics and teams of research which all study a different branch of science, but all have to cooperate to resolve problematics which are very important to society. For example, chromium-6 used on the surface of planes has been discovered to somehow be cancerogen. And so teams in the IRCP are called by the factories to find an alternative for a material that would have the same properties as chromium-6 without being cancerogen. I participated in the team of physical chemistry of surfaces. There, the researchers, what they do is they analyze surfaces in the atomic scale and in the visible scale, and they put links between those researchers in such ways that how to explain? They put links that they say, for example, when that happens in the microscopic scale, it happens like this on the large scale. For example, they mostly will study corrosion. Will study corrosion a lot. What I did, for example, Tuesday, I studied passivable and non-passivable metals. What the difference? Passivable metals will resist to corrosion, but not those that aren't passivable. It is asked a question to I as well as a cooperator, which is in the same situation as me, that is 13/14 years old, stage blah blah blah, and report C. And so we are asked the question that is explain why, what happens, and why does the passivable metal resist to corrosion, and what happens when the non-passivable metal is exposed. So, as the name of the team suggests, and as it is visible on the surface of the metal, we just assume everything is happening on the surface, and so we don't have to get too sliced like the metal or something like that. No, it's much simpler. We just have to watch. So watching using the eye, our eyesight. On eyesight, you can just see the difference of corrosion and its intensity. On the microscope, okay, surface. I forgot to show that, but surface there. On the microscope, we can see it better, as you can see with global corrosion everywhere on the metal, the non-passivable metal, and localized corrosion, which happens, is much more intense and localated. Also to know that the microscope does not give any information about the passivable metal. It's just gray. But this is not enough. We have to go even further, even closer. We'll use a big machine called TOF-SIMS. What happens? The TOF-SIMS sends ions. Well, this is a ray, but this is just an error. In reality, it's ions that bounce off of the material surface and gets into the detector. Each ion captures one ion from the surface of the material that is analyzed, and belong of this ion, it catches a certain mass, and then goes to the detector at a certain speed. And so using time, that means the first the lightest of those rays will get to the detector first, and then last will be those the heaviest, like gold or stuff like that. The lightest being like some stuff like oxygen, helium, stuff like that. So let's analyze titanium. We decide to analyze titanium, which is a passivable metal. It resists to corrosion, just as I said, and the detector gets us this curve. It is in French, obviously, because I know freaking. But this is intensity, this is time, so mass. This is oxygenated, oxygen, but the adjective, and titanium and pure titanium. And as you can see, there is a minority of pure titanium and a majority of oxidized titanium, which is much more intense. An hypothesis is that there is only oxidized titanium at the surface, and that the pure titanium has just been measured from the last rays that occurred after a little hole has been made from the first rays, and so it has been detected later and pure. And let's compare it to magnesium, which is non-passivable. It melts at the contact of air, and here is what the machine says: it is all and only pure magnesium. A conclusion we can make is that titanium is by default, by nature, covered with oxygen, which protects it from the ions that corrode and so attack the metal. While magnesium is not, and obviously, because it is not protected, it obviously reacts like all non-passivable metals. But it's not it. That's not it. If there are experimental science, there is also theoretical science. And what theorists do is they use data collected from experimentators' data, and so create a molecule which they know is which follows a certain algorithm in a certain reaction and all, and which knows it is just like reality, and it can save a lot of time and money. For example, let's say the reaction of diamonds in explosions. Imagine if this had to be experimented, it would take so much more time and so much more money than just making calculations and setting application programs to, I just hurt myself, programs to follow the calculation. And so they create the molecules in a program called model view, and it is problem with this is it is not precise enough. and the molecules are also set by hand on the program, and it's a freaking nightmare to those who only know this and cannot learn more sophisticated programs, which would take so much time to learn to use, and so they are locked. And here comes my role. In a new application you would build, I as a theorist should be able to create a molecule in which I can also modificate the distance between two atoms without changing the direction, and I should also be able to change the angle between three atoms without changing the distance, as you can see in the models. About 4 days, using the 4 days, the free time in the 4 days, 4 first days, I was able to finish my application. The molecule is of course savable and reloadable in model view, so that it can be modified in 3D, because that one is in 2D, because obviously it was too hard. In conclusion, I learned a lot of stuff in the difficulties of transport, in physics and chemistry, and also most importantly, I created a program, a program that will help numerous theorists unexperimented theorists to do what they could difficultly, can you say that? Hardly do before. Like they do in a 1 hour when they could do in an afternoon. It was everyone was nice, very nice and very pedagogic to make me learn stuff, what they did. And it was nice to them back, obviously. It was an amazing stage, extraordinary people, and I am very, very satisfied from it.